Today's daily code problem of the day is maximum number of events that can be attended, part 2, number 1751. For this problem, we're given an array of events where events of I, it contains the start day, end day, and the value of that event. So the ith event will start at our start day and will end at our end day. If we attend this event, we will receive a value of the value of that event. We're also given an integer k, which will represent the max number of events that we can attend in total. You can only attend one event at a time, and if you choose to attend an event, you must attend the entire event. So whatever the start day and end day are inclusive for that event. So we cannot attend two events where one of them starts and the other ends on the same day. So we want to return the max sum of values that you can receive by attending these events. So in example 1, we can see we can attend event 1 to 2 and 3 to 4, but we cannot attend 1 to 2, 2 to 3 because of the overlap. So the total best possible case scenario for this example is a total of 7, and that's because we can attend event 1 to 2, which gives us a value of 4, and we can attend event 3 to 4, which gives us a total value of 3, which add up to 7, and that reaches our max cap of 2 events. Down here in example 3, we can see that we have 4 total events we can attend, but we're only allowed to attend 3, so we attend the last 3 as they have the highest 3 values. So to solve this problem, we are going to take a dynamic programming approach, but specifically a two-dimensional dynamic programming approach because we need to keep track of two variables. One is going to be the value of our current event max, and our second value is going to be the number of events that we have taken so far with a max of k events. So we can go ahead and jump in. We want to initialize our dynamic programming array. So we're going to have a new integer 2D array, and we could call it dynamic programming. It's going to be a new integer, and our first value or our rows column is going to be of events.length, and our columns are going to be of k plus 1 because we're going to be able to attend at most k amount of events. So k plus 1 allows us to reach up into the kth value of a zero indexed array. Next thing we're going to want to do is decide how we're going to sort these events. So the best way to traverse these events is in order of when they start to finish, right? So we want to be able to look at our first event, then our second event, then our third event, then our fourth event, because that is going to line up with how our dynamic programming array is going to store the indexes of these events. But we want to focus on when the first event ends and the next event starts. So we're going to keep track of the end date, because by keeping track of the end date, we can go back to the previous end date and check if it overlaps with our start date. It'll make sense. So we're going to use our arrays.sort function. We're going to sort the events, and we're going to have a value A and a value B of our events. We're going to use a lambda function to define how we're going to sort them. So we're going to use our integer.compare. We're going to use integer.compare, and we're going to compare the A of one value and the B of one value. So these values are going to represent our end time in the array, right? So the 0 is the start, 1 would be the end, 2 would be the value. So these we're sorting by the end value of our events. Now we are going to loop through each event, and for each event I, we're going to consider whether to include it or skip it, and then we will build the optimal solution progressively one event at a time. And to do that, we're going to use binary search. So we'll first have to initialize our left, right, and then our valid index is going to be our indicator if we found a valid index. So we're going to have an integer left, right, and our valid index. Valid index we're going to leave as -1, which will represent we haven't found anything. Right will be equal to our I minus 1 value, basically the farthest we have gone so far, and our left will be 0. So using these three, we can do our binary search. So while left is less than or equal to our right value, our integer middle is going to be equal to the left plus the right minus the left divided by 2. Very simple binary search. And if our events of the current middle value we've identified, their end date happens to be less than events of our current index of its start date. So the end date is less than the current start date, this would be a valid occurrence. So we could say our valid index is now equal to this middle point because that is a valid end date. Then we can update our left equal to mid plus 1, so we can see if there is a further along end date that would be valid. This is like saying we are at day 3 and our midpoint for whatever reason is day 1. 1 is a valid endpoint, however 2 is also a valid endpoint, so we want to check 2 as well. So we'll also say, well, first we're going to want to fix our if statement, but then we'll also want to say else our right will be equal to mid minus 1. So if we don't find a valid index, we'll move our right to be behind the middle point, and we'll find a new middle point. So this will find the latest event that ends before the start of the current event. Next, we're going to use as many events as possible, so 1 to k amount of events. So we're going to initialize a loop, so for each integer j is equal to 1, as long as j is less than or equal to our k value, j can increment, because we'll either have 1 or up to including k amount of events. So with each event, we're going to have to decide, should we use this event as our jth event or skip it and save that jth event for future use? So our first option is to skip it. We're going to first want to identify our value, and then we can identify the skip value and our take value. So our value with the current index will be equal to the valid index, as long as it's equal to -1, or not equal to -1, because if it's equal to -1, it will be 0. As long as it's not equal to -1, we can get the valid index current value, as well as the valid index current total events taken value, and we're going to add the events of I of 2, so the current value we're looking at. So this is the valid index, the last valid job, or the last valid event, and this is the current event we're looking at. So this is the value, the total point value, adding up our current event we're looking at and the last valid event we can take. We can then decide whether we're going to skip it or take it by identifying how much points we would have if we skip. So if I is equal to 0, there's no reason to skip because there's nothing behind it. So 0, otherwise we'll say dp is going to be equal to I minus 1 of j. So we're not going to change anything. That's going to be the skip value, but there's also the take value. So int take is going to be equal to events of I of 2. And then we will decide what's the best option by saying if our valid index is not equal to -1, then our take would be plus equals dp of valid index of j minus 1. That's only if our valid index is not equal to -1. And then we can say our dp of I of j, we're going to update this value to determine whether it's best to take the job or not take the job, or the event, is going to be equal to the math.max value of our skip or take. So using this, we've now decided whether we're going to take or skip the event based off of whatever provides us the max amount of points. So now after filling out that table, we're able to simply decide what is the max value based off of the total amount of jobs we can take, and adding up all these values in our dynamic programming table. And we'll do that by simply having an integer called max, and we'll loop through our dynamic programming. We will loop through our event or our dynamic programming array and determine what the best solution would be by saying our max value is going to be equal to the math.max of whatever our current max is, or our dp of I of k. So the max amount of jobs taken at each index. And then we'll simply return max. So the reason we use a dp of I of k is because for each row I, we fill up their column k. So for each row of I, we look at every possible solution to fill up k. And so whatever values at k is the absolute max value you can get, including job I. So we look at each job I and say, should we include it or should we not include it? And we determine that by calculating the best possible course of action for each value of k. And that's it. So if we run this, passes our test cases, and if we submit it, it passes our solutions. So thank you, and follow for more daily code solutions.